Okay, so the first thing you're going to do when you look at a phase diagram is you need to see three regions. This one, and this one. And this one, which corresponds to high pressure and low temperature, that is going to be where it is a solid. And then this one over here, where it is at high temperature and low pressure, that is where it's going to be a gas. And the in-between one is where it's a liquid. So we look here at number 2 says, what state is the substance at a temperature of 200 K? So let's see, that would be right about here, and a pressure of 1 atmosphere. So we're talking right here. So you notice it is a gas. And what state is the substance at a temperature of 200 K, which is here, and a pressure of 5 atmospheres, which is here? So I go, and it's a solid. And then number 4, what substance is the state at a temperature of 250, which is here, and a pressure of 73, which is here? So that would put it in the liquid range. Alright, let's scroll up here for a second here. Number 5, what state change occurs at 1 atmosphere when the pressure goes from 100 kelvins, which would be here, so we're talking here, goes to 200 kelvins, which is over here. So we're talking about making this change. Alright, so we're staying at 1 atmosphere and we're changing the pressure this way. Well, let's see what we've got here then. Let's just scroll down a little bit. What we see here, what's happening is it's going from a solid here to a gas here. So it changed from a solid to a gas. I believe that's called sublimation. Let's see where I'm supposed to put it. I'm trying to write it here, sorry. Right, that was sublimation. Okay. Number 6. What state change occurs at 60 atmospheres when we go from 250 to 200? So we're going to 60 atmospheres. 60 atmospheres is way up here. Is way up here. And we're going to drop from 250 down to 200. So we're going from a liquid to a solid. That would be freezing. So let's go here and say freezing. Alright. Okay. Now number 7. What phase change occurs at 250 kelvins when the pressure goes from, now we're going to change the pressure, from 5 atmospheres to 60. So let's go up here and see what happens. So we go up here, and what we're doing is we are going to change from, let's see if I can remember now, we are going to go to 250 degrees here, so we're at this temperature here, and we're going to change from 5 atmospheres, which is here, to 60 atmospheres. We're going from a gas to a liquid, and that's called condensation. Condensation. Alright, what is the critical temperature of the substance shown? Now let's look at this. The critical temperature is the highest temperature at which it can exist as a liquid. And so what you do to find that, you just follow this lower arm out, all the way out to here. So don't take the left branch. Okay, so right here where D is on this one, that's its critical temperature, not the pressure but the temperature. So I come down here, it is 304. Number 9. At what temperature and pressure does a substance exist as a solid, liquid, and a gas? So that's called the triple point. And you can find the triple point. It is where it branches, right here. That is the triple point where it's both a solid, a liquid, and a gas, all at this one point here. So that would be at 5 atmospheres and 217 kelvins. So at 5 atmospheres and 217 Kelvin. Alright, number 10. At 300 kelvins, could you compress the gas into a liquid if you applied enough pressure? So we're going to go to 300 kelvins and apply a bunch of pressure. So let's see, let's go back up here. Let's see, so here's 300 kelvins. Oops. Here's 300 kelvins, and if I applied enough pressure, yes, I could do it. I haven't gone past the critical temperature. So yes, it could be condensed into a liquid. Once you go beyond the critical temperature, it cannot. But since I'm on this side of it, yes, I can. So the answer is yep. Alright, and we have one more. Which line segment represents the conditions where boiling occurs? Now let's recall that boiling is a state change between gas and liquid. So let's go up here and look. On all phase diagrams, we're going to find here's gas, here's liquid. It is this branch right here that represents where boiling and condensation occurs. So it's line segment BD. Okay, welcome to the back side of your homework. And again, we are asked to label the solid, liquid, and gas. It always goes the same. This region here is solid, this region here is liquid, and this region here is gas. So it says, number 13, at normal room conditions of 1 atmosphere and 20 degrees Celsius, at 1 atmosphere and 20 degrees of Celsius, it looks like we would be a gas. Carbon dioxide is a gas at room temperature. Everybody knows that. Well, let's see now. If room temperature was raised to 100 atmospheres, so I'm at room temperature and I'm going to raise it to 100 atmospheres, it would be a liquid. And actually in the CO2 tank that I keep in my room for demonstrations, if I tip it around, you'll hear it sloshing around. It is a liquid in there, just like a propane tank is at home. Number 15. If room temperature is raised to 9,000 atmospheres, ooh, that's really up there. So here I am. I'm going to raise it all the way up to 9,000 atmospheres. Look at that. I could compress it all the way into a solid. How funky would that be? Number 16. Dry ice is carbon dioxide sublimated into a gas at normal pressure, which is 1 atmosphere. What is the temperature of the sublimating? So I'm just going to go from 1 atmosphere to this boundary between solid and gas where sublimation occurs. And it looks to me like it's, let's say, maybe around -70. Number 17. At what temperature does CO2 sublimate on a planet? Ooh, I like this question. With an atmospheric pressure of only 0.01. So here's 0.01. And it would sublimate at a crazy, we'll call it maybe around -120. I like that question. Number 18. At what temperature and pressure does it change does it form a strange mixture of solid, liquid, and gas? That's called the triple point. Here's your triple point where it branches right there. It's both it's a solid, liquid, and a gas. So it looks to me like we're talking about maybe 5 atmospheres and -50. So I'm going to say 5 atmospheres and -50 degrees Celsius. What is the critical temperature of CO2? That's what number 19 asks. So the critical temperature is the highest temperature at which something can exist as a liquid. So you follow the lower branch to its stopping point and you check the temperature. And that temperature looks to me to be 40 degrees Celsius. So the critical temperature, 40 degrees Celsius. Can carbon dioxide at 60 degrees be compressed into a liquid state? No, because we're above its critical temperature. So therefore it cannot be, because we're above the critical temperature. Let's see, the next question says, at 60 degrees, can it be compressed into a solid state? Now, the critical temperature says nothing about solid, and carbon dioxide is pretty weird this way. So if I look here, at 60 degrees, I can still turn into a solid. that's a very unusual substance, but the answer in this case is going to be yes. It would not be with most substances, but with carbon dioxide it is. And finally, number 22, at what temperature does carbon dioxide at 100 atmospheres melt into a liquid? So I want to go from a solid to a liquid at 100 atmospheres. So here I have 100 atmospheres, and it would melt at this temperature right here, which looks to be about maybe negative 50-ish. So let's go down there and write negative 50 degrees Celsius. Thanks for doing your homework, kids.